Section 4.1, we're going to start talking about divisibility. We're going to have some divisibility rules, properties. Some of them are going to be properties that have to do with specifically dividing by certain numbers. And then some of them are going to be more generalized. We're going to be able to talk about, well, how does that look in a bigger context besides just this specific case? So I'll show you some of those things as we come across them. Starting with, we're going to talk about what the definition of the word divides means. If A and D are whole numbers, and we say that D divides A, it is written D at the beginning. It is a vertical bar. It's not a fraction bar. Okay, that is a vertical bar. If and only if there exists a unique whole number Q, such that A equals DQ, if D divides A, then D is a factor or a divisor of A, and A is a multiple of D. So just fill in the details, and then I'll do a specific example, and you're going to be like, oh, that's exactly what I thought you meant if you put numbers in. Okay? That's what I thought it meant. A equals Dairy Queen? Yes. In my mind, I was thinking DQ like disqualification for swimming, actually. All depends on your perspective when you see letters. I like Dairy Queen, though. Let's go there instead. Sounds good. Okay, so can you give me two numbers where you would think that one of them divides another one? Just give me an example. 12 and 2. 12 and 2. Okay, so 2, we would say 2 divides 12. So you'll notice the 2 is listed first, and we read it from left to right. 2 divides 12. Okay, it means that 12 is divisible by 2. And the reason is because 12 is equal to 2 times what? 6, and 6 is a whole number. So we would call 2 a factor or a divisor. And we would call, of 12, I should say. And then we would call 12 a multiple of 2. So we can use that language in either direction, depending on which one makes sense in our context. Okay, 12 divides 2, so 12 is a fact. I'm sorry, 2 divides 12, so 2 is a factor or a divisor of 12. We would say 12 is a multiple of 2. Okay, next one. For any whole numbers A and D, where D divides A, N, and N is any whole number. If D divides A, then D divides N times A. So we'll still use our same examples we just had before. We said 2 divides 12. So that means that 2 divides 12 times N, no matter what N is. Okay, N has to be a whole number, so N is 2, N is 7, N is 563. Okay, if 2 divides 12, 2 is going to divide 12 times that number. And you guys know that this is true because you use it with fractions before. You have used it with fractions before. For example, we know that we can write 12 over 2 and that becomes a whole number, right? We can divide out the 2. Well, the same thing's true if I write 12 times N over 2. Can I not still cancel out the 2? Well, of course I can, because the 12 and the N on top are multiplied. And if you want a specific concrete example, we can say something like where N is equal to 3. We'll do that one because I can do that one in my head. This is 2 would divide 36. Does 2 divide 36? Well, of course it does. Can I divide it like that was a fraction where I have a 36 on top and a 2 on bottom and it be a whole number? Of course I can. That's all this theorem says. Okay? All right, the next 5 examples, I'm going to let you write them all down, and then I'm going to explain all of them kind of one at a time, okay? Because you guys are going to want to write and not listen to me anyway, right? Yes, that's what's going to happen. Okay, so the first one. If D divides A and D divides B, then D divides A plus B. Second one, if D divides A and D does not divide, so this division bar with that, the division symbol with the bar in the middle of it like that means does not divide, then D does not divide A plus B.
Is that if D doesn't divide B?
Thank you. Yes, I left that out. Now it looks like DTB. Let me try that again. That's better. All right, the third one looks a lot like the first one. D divides A, D divides B, okay? Then D divides, oh, I'm sorry, I need one more condition before my then, sorry. I need A to be bigger than B, bigger than or equal to B. I'll explain why. Then D divides A minus B. If D divides A, D does not divide B, and A is greater than or equal to B, then D does not divide A minus B. All right, last one. If D does not divide A, but D does divide B, so sort of it looks like reversed of the sentence before, right? Still A is greater than or equal to B. Then D does not divide A minus B. Okay, so let's keep going with division by the number 2, because it's really easy to think about in our heads, because all it takes to be division by 2 has to do with being even, right? It's easy for us to work with it. So let's take this and say that we have 2 divides 12. So let me use another color, and then I can actually write it on top of here so we can see it. Let's say we have 2 and it divides 12. And give me another number that 2 divides. 4, thank you. Now what would happen if I add the 12 and the 4 together? You get 16. It's still going to be divisible by 2. Okay? So why is this happening? Well, it's happening because multiples of numbers are a closed operation. We've talked about closure before, right? Closed is the idea that if you take 2 of some kind of number and you add them together, you get that same kind of number. Whole numbers are closed. Well, even numbers are closed as well. Even plus even is even. Right? We talked about the fact that odd doesn't work that way. Odd plus odd's not odd, so we can't do that. But if you think about it, this works for any multiples. There's nothing special about the multiples of 2. Think about the multiples of 5. When you add 2 multiples of 5 together, don't you get another multiple of 5? Yep. How about if you add 2 multiples of 7? Don't you get another multiple of 7? Yep. So that's exactly what this statement is saying, is that when you take 2 multiples of something, right, because that's what the B and the A are, is they're multiples of the number in front of it. So if you take 2 multiples of the same value and you add them together, you just get another multiple of the same value. So you can generate lots of other things that you're going to be able to divide by your original number D. In our case, we did 2. B is saying, however, that if you do just one of those, like let's say we did again the 2 divides 12 here, but the other number is not divisible by 2, like 2 does not divide 9, then when you add the 12 and the 9 together, you've disrupted this ability, right? You do not have the same property, because 12 and 9 were not both multiples of 2, so when you add them together, they're not going to be a multiple of 2 either. And there's nothing special about this one. You'll notice that it feels almost like I'm missing something. This says D divides A. This one says D does not divide B. Well, it could be that I just switched the order of these things, right? I could have listed the 2 does not divide 9 at the beginning first and 2 does divide 12 at the end. And the reason they don't do that is because addition is commutative, right? If I do A plus B, it's the same thing as B plus A. So that's why it's not listed twice. Okay? The subtraction's different in the sense that we have to list 3 pieces here. So again, if you have 2 numbers that are both divisible by 2, and you subtract them, aren't you still going to get a number divisible by 2? Yeah, 12 minus 4. If I use the same numbers I had before, give me 8. Okay? Why do you think that there's this extra condition in here about A being greater than or equal to B? So it's not negative. We still are not working in negative numbers. Chapter 5, we're going to introduce integers, which includes negative numbers. We're still working with positive numbers here. Okay? So now, technically, is the statement still true for integers? Yes, it still works, right? If I got negative 14, is negative 14 divisible by 2? Well, yeah, I mean it is, right? It still divides evenly, right? That still works. But we're just working only in positive numbers. That's the only reason there's this extra condition right here, okay? Now, also here, notice that because of the subtraction in any order business, we're writing both of these last two statements, which are sort of the same thing, right, out separately. Because basically we're saying that whichever number comes first or second, it doesn't matter when you do the subtraction. When you do the subtraction, you're still going to get something that does not divide, right? It still does not work. And we'll get more back into some of these later with some examples where you can see how they're going to ask you questions about them. But before we do that, we're going to do some very concrete examples of how we know numbers are divisible by something else. Okay, you guys ready? Because we're going to start with the 2 that we keep using. We should start with 2 because we keep using it. Okay, let's actually talk through them first before I just show you the next slide. Okay, a whole number is divisible by 2. How do you know if a number is divisible by 2? If it's even, what does it mean for it to be even? The units digit has to be even. So what does the units digit being even mean? Okay, that's true. What else did you have? Somebody said something else. The last digit. So that's important to realize. Our last digit has to be divisible by 2 only, right? So it doesn't matter what all the numbers are that come at the beginning. It's just the last digit that has to be divisible by 2. So which of those digits are they? 0, 2, 4, 6, and 8. Or 2, 4, 6, 8, and 0. Right? Those are the ones. All right, the next one on your paper is divisibility by 5. How do you know if a number is divisible by 5? The units digit, still, it's all about the units digit, right? The units digit in this case has to be 0 or 5. And then the last one is divisibility by 10. Units digit has to be 0. These 3 are grouped together because they all have to do with just the very last digit. Okay, all we have to look at for divisible by 2, 5, or 10 is the last digit of the number. None of our other divisibility properties will be like this. It's just 2, 5, and 10. So jot those down. The units digit is even. The units digit is divisible by 5, or the units digit is divisible by 10. Okay, what's next? 4. 4 and 8 are grouped together. They're going to be on the same slide here in a moment. You may or may not have ever seen the divisibility. You probably see the first 3 we did. Have you guys seen those 3 before? Most of you seem to know basically what you were going to be answering with me when I was asking you questions about 2, 5, and 10. Does anybody remember or have heard of one that's a divisibility for the test for 4? If not, it's okay. It will, that is a condition, right? If the number is not even, it will not be divisible by 4. But are all even numbers divisible by 4? Not all of them, in fact, just half of them are, right? Every other one will work. And so we have to sort of have a way of figuring out which ones do and which ones don't. Well, when we do the divisibility test for 2, we look at the single last digit, and if it's divisible by 2, then the whole thing's divisible by 2, right? When we do it for the value 4, 4 is the same as 2 squared, agreed? So when we had the number 2, we looked at the last digit. When we have the number 4, we look at the last 2 digits. If the last 2 digits as a whole number, you know, like 24, 36, 42, whatever they are, if those 2 digits as a whole number are divisible by 4, then everything else, you know, the whole digit of the whole thing is divisible by 4. All you have to do is look at the last 2 digits. Okay? So like 24 would work, right? If the 24 were your last 2 digits, that would be good. 44, that would be good. 42, not going to work. Okay? So if you do divisibility test for the number 2 and you look at the last digit, and you do divisibility test for the number 4 and you look at the last 2 digits, what do you think you might do for the divisibility test for the number 3? Or for the number 8? What's next? Sorry. The last 3 digits for the number 8. If so the last 3 digits as a whole number are divisible by 8, then the whole thing's divisible by 8. And you might think, okay, but I don't know 8's digit to the, I mean, 3-digit numbers. I mean, like, that's true. You probably don't. I don't either. Occasionally might look at something and it has a convenient number in there that you can just do in your head, right? Some sort of mental process there. But even so, if you were doing it by hand, which is what your kids would be doing in your classroom, would it not be easier to divide the last 3 digits by 8 than all 8 digits by 8? Absolutely. So it still cuts down on the processing time if you consider it from that way. So the divisibility test for 4, a whole number is divisible by 4, if and only if the last 2 digits as a 2-digit number, not each of them individually, but the whole 2-digit number is divisible by 4. And for 8, the last 3 digits as a 3-digit number is divisible by 8. So why might you care if something's divisible by 8? Well, you know, what if you had a package of crayons and you knew how many crayons were in the package and you knew how many kids were in your classroom? And there were 8, or there were 4, or there were 16, or there were whatever the number is. Wouldn't it? So this divisibility test idea is very practical for being able to shortcut the process without having to go grab a calculator to do it, honestly, okay? So there's 2 more that occur in pairs. It's 3 and 9. You might know the test for 3. Amy's smiling at me. She thinks, what's the test for 3, Amy?
If you add together all the digits and it's divisible by 3.
Who's heard that before? Did you guys know that? Somebody's like, what did she say? I'm not even sure I heard what she said. Say it louder for me, Amy.
If you add together all of the digits and that's divisible by 3, the number will be. And I don't understand at all why it works, but I think it's cool.
Yeah, so if you had the number, say, 400 and, I shouldn't have said the word and, but 426, that would work. 426. And you added the 4, the 2, and the 6 together, what do you get? 12. Is 12 divisible by 3? Yes, so 426 will be divisible by 3 as well. There's actually, I'm not sure if it's an actual proof, but there's an argument as to why it works in your book. So if you're curious to be like, why does that work? That's kind of crazy. All right, so if you know the test for 3, you actually know the test for 9. You just may not be aware of it. Test for 9 is the same thing. You just add all the digits together, and if all the digits added together are divisible by 9, then the original number is divisible by 9 as well. So my number example where I did 426 would not be divisible by 9 because 12 is not divisible by 9. Okay. And that's what these 2 tests are. Whole number is divisible by 3 if and only if the sum of the digits is divisible by 3. It's divisible by 9 if and only if the sum of the digits is divisible by 9. I heard the divisibility test for 3 a long time. I mean, like, probably a decade before I heard the divisibility test for 9. Which is kind of crazy because they're the same thing, right? You'd think that if you heard one, you'd heard the other, but
It's harder to divide by 9. I don't know.
yeah. It's even a more practical divisibility test to do divisibility by 9 than even by the 3. All right. I'm going to just let you write down the next divisibility test, and then I'll show you how it works, because there is absolutely, I've tried to make a good way of writing it down to show you what it does, and I have been very unsuccessful. So here's what it is. Divisibility test for 6, or for 11, and we'll talk about the 6 after that, so you can write that one down too. But divisibility test for 11 says, a whole number is divisible by 11 if and only if the sum of the digits in the places of even powers of 10 minus the sum of the digits in the place of odd powers of 10 is divisible by 11. And then since it's on the same slide, I'll go ahead and read the second one too. Divisibility test for 6. A number is divisible by 6 if and only if it's divisible by both 2 and 3. And we're going to talk a little bit more about that one and how it generalizes here in a second. So if you'll jot that down, then I'm going to show you what in the world that first one could possibly be saying. Okay, I'm going to make up a number. And I'm just going to make it long so that we can actually talk about this a little bit differently. I just made it up, so this is not going to probably be divisible by 11 because the odds of that happening are probably not very high. Okay? It talks about even and odd powers of 10. So you guys know that each of these are in a power of 10 position, right? It's 10 to the first location, 10 to the 10 squared, 10 cubed, 10 to the fourth. Okay, everybody good with that? What this is saying is that if you kind of group every other number sort of together, so I'm going to circle every other number in blue. So if you added up all the ones that I circled, so somebody real quick, add those up. What is 1 plus 4 plus 6 plus 9 plus 5? 25? Okay, so I'm going to write that down in blue. That one's 25. And then I'll do the same thing and we'll do green. Okay, the other ones I'm going to underline in green. Let's add all the ones underlined in green up. 2 plus 0 plus 1 plus 8. It's 11? Okay, 11. What this is saying is that if you take and you subtract these two values from one another, so what do you get when you take 25 minus 11? 14. If this value is divisible by 11, then the original number was divisible by 11 as well. So doing this process really isn't hard, but writing down what I just did is really weird. So is 14 divisible by 11? Well, no. Since 14 is not divisible by 11, 1, 2, 4, 0, 6, 1, 9, 8, 5 is not either. I am not sure on that one. And I have taught divisibility out of several different textbooks, Alyssa, and this is not always present in every book. So it certainly must not be popular enough to show up everywhere, because the last book that I taught out didn't have this one in it. Yes?
So it doesn't matter if you're subtracting the odds from the evens and the evens from the odds.
It really
it's just
doesn't.
the bigger number first.
Yeah. Yeah, it really doesn't matter whether it's just the difference between the two. So since it's the difference between the two, we can go in either order. Yeah, it's a good point. Did everybody catch what she was saying? I just did the larger minus the smaller. Okay, I would like for you to get a partner. I think we have an even number. No, we don't have an even number of people. So I'm going to have 3 of you in one group. So I don't care who you want to grab, but grab somebody and say, hey, you're my partner. And I'm going to give you a list of numbers. So let me just speculate with you. Why do you think that this divisibility test for 6 might work? Yeah, 6 factors into 2 times 3, right? That's sort of what it seems like. What I'm going to do is I'm going to give you a list of numbers. And I want you to try and figure out, there's another condition present here. You just can't see it with this example. Okay? You can't see what the condition is. So I want you to try and see if you can figure out what the other condition is besides 2 times 3 is 6 that's going on here. I'm going to give you some examples and some non-examples of when the 2 numbers multiply to being the value and it works. Okay? So find a partner, move around, and I'm going to put the examples and non-examples, I'll put them on the slide. So find somebody, move to where you can talk with them. Y'all are not moving very much. Who are you going to work with, Lauren? No, we're not even today. I think we have 11 now in the class. You got a group of 3 back there? And you ladies are together? Excellent. So everybody has a partner or a couple partners. Okay, so I'm going to put on the left examples. And on the right, I'm going to put non-examples. Okay? So what we have right here, whoops. So some examples. Oops. So 2 times 3 is 6. So if it's divisible by 2 and 3, it's divisible by 6, and vice versa. I mean, it has to go both directions. It's an if and only if statement, which means you have to be able to make it go in either direction of the statement. Divisible by 6 means it's divisible by 2 and 3. Divisible by 2 and 3 means it's divisible by 6. You guys with me on that? Okay, got to go both ways. So another example would be 3 and 5, and then 15. Another example would be 4 and 3 and 12. Another example, I'll give you 2 more, let me think. 2 and 7 and 14. Six and 5 and 30. These are all examples that I could change all the numbers in divisibility test for 6, and I could say the divisibility test for the number 15 is that it breaks down into 3 and 5. Okay, you guys with me? Like if you took all of these numbers that are here and you replaced them with the 3 that are grouped together down here, they would all work. Okay? So now I'm going to create some non-examples. 2 and 4 and 8 is a non-example. 3 and 9 and 27 is a non-example. 4 and 6 and 24 is a non-example. 10 and 12 and 120 is a non-example. Okay, so you and your partner are going to try and see if you can figure out. Did you have a question? Don't try and answer the question for me yet,
No.
but did you have a question? Yes.
How is 2 and 7 and 14 divisible by 3?
Has nothing to do with 3. I would take the 14 and put it where the 6 is.
Oh.
I would take the 2 and the 7 and put it where the 2 and 3 is. Okay, did everybody see? Are you good with that? Okay. All right, so I want you to try and figure out what is it about these that works and these that don't. What is it that these have in common that these have differently? Okay, so try to keep your voices down a little because I'd like for every group to try and have some kind of figured out yourself. No, don't talk out loud. Shh. I'll come around, okay? Hold tight. All right, we got a lot of examples, a lot of non-examples, right? We'll let Gretchen see if she can explain it so that you guys get it because she's the one who saw it first. And then if her language doesn't make sense, we'll let Hannah do it second because she had the second idea, okay? So Gretchen, what did you notice about these to try and figure out what the difference is?
So all of the examples, 3 times 5 equals 15. 3 and 5 have no common denominators. 3 is made by 1 and 3, and 5 is made by 1 and 5. They have no numbers in common that can multiply each other. Versus 2 and 4, 2 and 4 multiplied to each other gets 8 in the non-examples. 4 can be divided by 2. They both have a common denominator of 2. 3 and 9, they both, in the non-examples, they both have a common denominator of 3. And that made me question in the non-examples why 4 and 6 was a non-example because 4 and 6 can't be divided by 4. They both have a common denominator of 2. And so the reason why the examples work is because in the whole like divisibility test for 6, 2 and 3, or 6 has to be divisible by both 2 and 3. 2 has no common denominators with 3. And so to make sure the whole number is divisible by 6, you have to make sure there was one test once for another test, and these tests have nothing to do with each other.
What do you guys think? Make sense?
That makes sense.
Yeah. So the basic idea, and you keep using the word denominator, which isn't quite right. We should use factor or divisor would be fine. But yeah, the basic idea is that in order to take a number and to make a divisibility test for it, you have to break it apart into 2 factors that have nothing in common in terms of their factorization. So 24 is a really good example because if you take the number 24, it can be broken down into 2 and 12, but 2 and 12 have a factor in common, 2. It can be broken down into 3 and 8, no factors in common, so that one works, right? And in fact, it's really nice because we even have a test for 3 and a test for 8. And then if you look at the other one, which would be 4 and 6, 4 and 6 aren't going to work either because 4 and 6 have factors in common, namely a 2 in common with the factorization. So that's what makes this test work is that you are able to break down the number into factors that have no factors themselves in common. Is everybody with me? Okay, so like if I gave you an example, and I give you an example here that 30 is 6 and 5. But what's another test you could use for 30? 3 and 10, right? 3 and 10 would work. 3 and 10 have nothing in common, so that'd be another test that you could do. And it'd be a nice test because, you know, I have a test for 3, I have a test for 10. So that is the divisibility test for 6. All right, so let's do the last example, or the first, it's actually the first example, but as our last thing for today. we're going to, without using a calculator, to decide if the number we are given is divisible by 2, 3, 4, 5, 6, 8, 9, 10, and 11. Now, a couple of things about this. I'll let you do it in your groups, and then we'll make sure that everybody's on the right track. A couple of things about this. When this says to do this without your calculator, your book is not going to require that you justify your answers. But if I ask this, and when I have asked this in the past on the test, you have to be able to tell me why. All right, because what I want to know is I want to know, did you really do it without a calculator? And if you can't give me a justification for why, or if you actually did it out longhand where you tried to divide it out, then you didn't really use the divisibility tests. Are you guys with me? So go ahead and go through each one of these factor or possible factors and to decide it works or it doesn't, and then whether you write it down or not is up to you. But I would suggest you write down why. Why does it work? Why does it not work? Yes. There isn't a test for 7 as far as I know. There's just not a shortcut test. Okay, which one are we all on? Which number are you looking at right now? Which one?
The last one.
The last one? Ashley, Jessica, where are you guys at?
I've already done all the tests. I'm just writing.
Okay. Hannah, how about your group? Kelsey?
I'm on 6, but I've been writing.
I'm ready to focus.
Okay. Lauren, Gretchen, Jasmine Rose?
12 and 12.
Okay.
I always like to do this. I don't know why. If I have the rules in front of me. You might have answered this at the beginning of class. Oh, but did you say grade as our test graded? Not yet.
No, not yet.
I'm sorry. I was at my
You're fine.
drop a class.
Yeah, it just didn't happen today, over the weekend. Busy, busy. But you'll get it back Wednesday.
I just
Is it? Elisa, it is. Today's the last day.
I believe so. It's
Okay.
so late in the semester.
Well, not for the class that started last week.
Oh. Ashley, it's today the last day to do the drops.
Yeah, that's why I had to do that.
Okay, let's run through these. We've got 1 minute left of class, so let's just make sure everybody's on the same page in terms of the yeses and the nos and the why. I'll just check mark if it's a yes, and I'll put an in or whatever if it's a no or something like that. And then we'll talk about the out loud, what you should have had written down, and hopefully that you guys already have those done. So is it divisible by 2? No. Why not? Right, this one doesn't work. Because the end digit, basically because the 5 at the end, sorry, that's not what I want to do. The 2 does not divide the 5 that's at the end of the number, right? How about 3? Yes, why? Yeah, 2 plus 4 plus 1 plus 5 is what? Is it 12? Yep, and 3 does divide 12. All right, how about the number 4? No, and you actually could just say it's not even. I mean, that would be okay, right? Definitely is a condition. But you could also say that the 4 does not divide 15, right? Because it's the last 2 digits. How about 5?
Yes.
Yes, why?
It ends in 5.
Yep, it ends in 5. And I'm not doing anything I just said I was going to do with my check marks and not writing anything down because that's just so hard. How about a 6? No, why not?
Was it not visible by 2?
Yeah, that was the test, right? It's not divisible by 2. How about 8? No, and this is actually a really good example because the 8 does not divide what? 0, 1, 5. So because of the 0, it's easy to see on this one. How about 9? No. We summed these all together and we had 12, correct? And 9 does not divide the total 12 that we had from before. How about 10? No, why not? The last digit does not equal 0. How about 11? No. So when you did 11, what you should have done, just a reminder real quick, is add up 2, 0, and 5, which gives you 7. And then what's the other ones? 4 and 1, which gives you 5. And subtract. 7 minus 5 is 2, and 11 does not divide 2. All right, so we'll pick up there next time.